So we have Aryan, Sivatsav, Dev, Dhanushri, Chris, Prisha, Rehan, Sarah, Sivatsav, Sunarka, and Pranit in the classroom. Hey, Alright. So, in the class today, I had sent a message again saying what are the things that we are going to cover today. So, one was, we had planned to cover linear functions, but we could not do that yesterday because we spent most of our time talking about the operations with rational functions, rational expressions. So, today we will cover nonlinear functions, which include function understanding, what is function, what is not a function, what is composite functions, and then we will look at some things that we have covered in the past, which is isolating quantities and solving equations with multiple variables, and then converting a word problem into equation. So many other things that we are going to cover, we have covered in the past because some of you have been with me for some time. These are the concepts that we have covered in the past, but again, as I mentioned, from February we have started a repeat of the entire syllabus. So in next 5 to 6 months we'll cover the entire syllabus for SAT one more time, and whoever is planning to give SAT test in coming months, this will be a good opportunity for you all to revise. Yeah, so I think we have a quorum, we can get started. So first thing first, we want to talk about non-linear function. But before we go to non-linear function, we want to understand if we are all on the same page with respect to understanding what is a function. Any simple definition of what is a function? Anybody? Or what do we mean by a function? And I'm not looking for any mathematical definition. I'm looking for a very generic understanding of what comes to your mind when you talk about a function or when you hear about the term function. Yes, also.
Like in general terms, a function is just how something works.
Okay. How something works, yep. Okay. Anything else? Anybody? Yes, Chris?
Usually just like f of x equals something.
Right. That's a mathematical definition of it. So let's put all the things together and then try getting a view or building a view around this. So yesterday I used a marker which is not a dry erase marker. So that's why you would see some extra lines on the board, but yeah. So when you say function, one is a function, a marriage function, birthday function, any good or bad reasons for celebrating. But if you relate that in practical terms, a function is something that defines an outcome. Meaning, somebody turned, let's say, when I turn 60, I'll celebrate, and there'll be a function. Function is nothing but an outcome of me turning 60. I'm not turning 60 anytime soon. I still have little more than a decade to go. But on a serious note, a function defines an outcome. When you celebrate a function, you're trying to celebrate a certain outcome. Somebody getting married, that becomes a function, right? So function or the celebration is just nothing but just an outcome of the event, which is marriage. So in mathematical terms, when you look at it, it denotes the same thing. It says something is happening based on certain reasons. Now, if I say function of x, this is x is marriage probably in layman's term, gives you this. Meaning, for this event, this is your outcome. Or you will say, okay, I will denote or represent the marriage of x as y. So function of x, which in simplified form I will say as y, gives me this outcome. So whenever you look at any function for that matter, now we will stay away from all the function examples that I was giving, marriage function, birthday function, whatnot. Now we'll come to mathematical side of it. When you say a function that simply represents an outcome based on certain event or based on certain value. So this is the function of x and this is the outcome. So every function that we'll deal with hereafter will have certain input and will give you one output. So when you have, let's say when you give in this function y equal to fx equal to x squared plus 1, or if you don't want to deal with y right now, let's keep it like function of x equals to x squared plus 1. For every value of x, there'll be a corresponding outcome. It's like when I turn 39, there's a birthday. When I turn 40, there's a birthday. Then when I turn 45, there's a birthday. When I turn 48, there'll be a birthday. Likewise. So every value of x, every event will give you an outcome, or every value of the variable will give you a corresponding outcome. And remember this, there'll be only one outcome. I cannot have 5 birthdays. So that's the basic definition of a function. In mathematical terms, for every output, there's one and only one output. What did I say? For every input, there's one and only one output. So when you put x equal to 1, you will get 1 squared plus 1 equals 2. When x equals 2, you get 2 squared plus 1 equals 5. When x equals 3, there is 3 squared plus 1, which is 10. So the basic premise or the definition of function would be, for every value of, for every input, there will be one and only one output. Yeah. So that is the basic definition of a function. You will never have a function where for one value of, or for one input, you will have more than one output. So that's what we have to keep in mind, that I will never have a function giving me more than one output for one input. Is that a fair point? Is everybody with me? Yeah. And if you want to relate that in the most lame form, you will never have 2 birthday celebrations for 1 year, right? Same thing relates to the function also. Yeah. All right. So this is what do we mean by a function and what we will not call as a function. If there's ever a scenario where for one input you are getting more than one output, that will not be aligning with our understanding of function, and that is not going to depict a function. Is everybody okay? Sunarka, Rehan. See, I like Anshu and Prisha for they being prompt. Whenever I ask a question, they are the first one to raise hand. So at least that gives me kind of confidence that okay, they are always paying attention. So all of you, whenever there is a doubt, don't take time to respond or to ask questions. Okay, that's what makes me more comfortable as a teacher. All right. So this is about the function part of it. Now we can have multiple flavors of a function. Now you saw that okay, there's one scenario of a function where I said I have a function x where function x equals, let's say, x cubed minus 2x plus 7. I have another function which says this function x equals, let's say, 4x minus 9. And one thing that you would notice in a function is this is a function of x. So everything is relating to x. You will never ever have a function of x which will say x squared minus 2y plus 8. This is illegal as far as the definition of a function goes. You are saying that this is a function of x. If I say how much marks I will get in my exam is a function of how many hours I spent studying the subject. My output, my result will be a function of how much effort I am putting. It cannot be how much hard work my neighbor does. Yeah. So that's the scenario here. It's a function of x. This is my hard work. It is independent of what my neighbor does. Yeah. So always remember that when you are dealing with a function, you are dealing with only one variable. That is the variable of x. Okay. Now, so we saw two functions in both the scenarios. We saw that its function x is relating to x. This is second one. Now, how about function of function? Meaning, if function of x is actually function of g, okay? Meaning, let's look at a practical scenario. When I turn 40, I keep on disclosing my age all the time. Anyways, that's an open secret now. So let's say when I turn 40, 50 now, 40 is history. When I turn 50 and my child turns 18, we'll have a celebration. So here the celebration, which is the outcome, is a function of me turning 50 as well as my child turning 18. Okay? So when that happens, when you're talking about an outcome being a function of function, that is when it is called a composite function. So if I say function of x is function of g, where g of x equals five x squared minus 9. And so here I have not related that way. So let me put it this way. Let me write this like a composite function. Function of g of x equals let's try finding it out, okay? Where let's say we have to find out function of function, okay? Where we know that g of x equals, let's say 3x minus 2, and function of x equals, let's say 3x squared minus 7, let's say. Now if I say find out, I have two independent functions, g of x, and we have another function, f of x. If I say find out function of g of x, how much would that be for the value of x equal to 7? Why 7 always? Let's say 5. You know what is g of x, how you're getting the output here, and this is a relationship that you are given, and function of x is given as this. Now when I say make a composite function by combining these two functions and find out the value of function of g of x, how much that would be for the value of x equal to 5? I'm not sure if I stated the question correctly, but anybody in the class, if you want to try and let me know if you know how to solve it. Yes, Vishal.
I got 202.
You got 202. So one bad news is I don't like answers. So keep your answer handy with you, but I would want whoever says that he or she has solved the problem, I would want you to explain what did you do.
So I put 5 of x equals 5, so I did g of x, so plugged in 5 in g of x function, which got me 13.
Okay.
And when you put, so since it's g of f of x is g of x, so g of x is now your x for f of x, so you plug in 13 into f of x in each case.
Okay, yeah. So Vishal, would you want to explain just the approach part of it? I would not be really worried about the answer, but yeah, just the approach.
So first, since it's in the parentheses, g of x, we put 5 in x. So 5 times 3 is
15.
15 minus 2, which is 7. 7, then you do 7 squared, 49 times 3. Oh wait, I did it wrong.
No, so
Which is 147. And minus 7 is 140.
okay.
So that's how I got the answer.
Okay. Anybody in the class who's not clear about what do we do when we are dealing with composite functions or function of functions? And right now, this is the simplest form that we are trying to understand. And again, I'm just trying to get a sense of who all knows versus who all doesn't, so that I will approach solving it that way. Anybody? Sunarka, Shravya, Srivatsav, anybody? Okay, let not bug you guys. Let me try simplifying this. So I think Vishal and Praneeth, they tried solving it, and I don't think there was anything wrong with the approach. Calculation might have gone wrong, right? Like the way calculation was going wrong for me yesterday. So now let's come back to this one. So whenever you have function of functions, if I say evaluate this for a value, that will be my last step. What you can do is, you will have to always look at breaking it down. Ultimately, any function, be it a simple function or composite function, ultimately you are trying to convert this into a form of a equation or expression, whatever you call it. In the form of the variable that you are dealing with. You don't like something like function of g of, and then function of let's say k of x. This looks very cryptic, right? You want to simplify this and get to a form of x squared, x cubed, whatever it is, like a regular polynomial. So to get to that, first thing you will say, okay, fine, I don't want gx. I have a more simplified value of it. So function of g of x becomes function of g of x is nothing but 3x minus 2. This becomes my new variable that I'm going to deal with. And since I have the function definition of f of x, and instead of x I have 3x minus 2. So wherever I have x, I'll just replace that with 3x minus 2. That is going to be my approach. So here, now we converted this function of g of x into a simpler form of the function, where my variable is not x, it is rather 3x minus 2. And then by the definition we know function of x is nothing but 3x squared minus 7. So wherever you have an x, you will replace that with 3x minus 2. So this, now we are trying to get to function of 3x minus 2. So that would become function of x is 3x squared minus 7. So this is my x, this is my new x. So wherever I have x, I will put that with 3x minus 2. I will replace that with 3x minus 2 minus 7. This becomes my new polynomial for the composite function. Are you guys okay? So composite function, if I want to repeat, composite function is a function of function. It could be 2 levels of hierarchy, it could be 3 levels of hierarchy, it could be n level of hierarchy, depending on what kind of problem you're dealing with. Most likely the kind of problem that you guys will deal with, maximum would be 2 levels of hierarchy, where it will be function of function. But if your examiner gets more funny, they might give you 3 levels also, and the approach will remain the same. You will keep on knocking off the function thing like you break the bracket open. So as long as you keep breaking it from the smallest hierarchy to the next level hierarchy, and then once you come to this final point where you have one function and one variable inside that, then you will replace that and you deal with it. Yeah. So here in this case, now we know that we have just replaced that. So I'm just creating some real estate here. So this is my new thing. So I can either replace the value of x here with 5, because we are trying to evaluate this for a value of 5. We can put it here, or you can first expand this polynomial and then you can deal with it. Any which way is okay. So this becomes a minus b whole square. So it will be a squared. So 3x squared will be 9x squared minus 2ab. So 2 times 2, 4 times 3, 12. 12x plus b square, which is 2. 2 square minus 7. So this becomes 3 into 9, 27x square minus 3 into 12, 36x plus 12 minus 7. Now this becomes 5. So now you put the value of x and you get your answer. But when it comes to composite functions, though the name sounds little fancy and cryptic at times, but it has nothing complicated about it. As long as you keep breaking it to get to the most simplified form and get one variable in one function form, you are good. Is there anybody in the class whom I was able to successfully get confused? And I'm okay, I can do it one more time. Yes or no? Pin drop silence. Is everybody clear? Rehan, Savya, Sunarka, Sivatsa, Prisha, Anshu, Vishal, everybody? Okay. See. So this is called personalization, right? If I don't call out the names, everybody keeps thinking who has to respond. If I call out the names, then probably it makes it easy for you guys. All right. So as I said, when you're dealing with composite functions, let's look at the worst case scenario. If somebody says find out function of g of k of x, find out the value of this for, let's say, x equal to 3, and you are given function of x equals 2x minus 1, function g of x is given as x cubed minus 8, and k of x is given as, let's say, x squared plus 7, not 7 this time, 6. So when you have this, the way you have to approach is, if I break this guy, if I break it open, get the value of kx, the innermost function that I have in this one. If I put this here, then I can knock off k, and this part becomes x squared minus 6. Yep. Now you still have two functions. So now you know that this is g of x. Here you don't have an x, you have x squared minus 6. So g of x is x cubed minus 8. So wherever you have x, you will replace this value, and then you can break open this guy, and then you have the final function. So though whatever we are doing here, it might look a little bit scary, but in the most practical situation, you will deal with maximum 2 levels. I have not seen many questions in Khan Academy also where it goes beyond 2 levels, but don't be surprised if you get 3 levels, because that is also by definition a composite function, when it's a function of function or function of function of functions. Okay, so there is nothing written in stone saying now you will not have 3 levels of function. But regardless, be it 1 level, 2 level, 3 levels, your approach remains the same. You're ultimately trying to get to a point where you have a function and a variable inside the bracket, and then you have a rule defined for that function, saying, okay, this function works in this way with this relationship. Okay. Any questions so far?
No.
Yep. Okay. Okay. All right. So now, the remaining things that we're going to discuss in the class today would be more around dealing with few examples of linear equations, which I'm pretty sure everybody knows to the nth level of detail. So what we will try doing in the class today is, we will look at some linear functions, linear equations, some polynomials, and try relating that with the word problem. So that's the reason why I sent a couple of sample questions also that we'll try solving in the class. And purposefully I'm planning not to solve it for you guys because I'm more than confident that you guys know how to solve it. So that's why, just in the interest of time, I will flash those questions here on the board and I'll let you guys try, see who gets the hands dirty and how much, and are you able to clean that dirt by yourself. If not, obviously I'm here. So before we go there, so I mentioned that in this class we're going to talk about nonlinear function, and interestingly I've not talked about it yet. So when you say linear function, now by definition we know that when you're talking about a function, you're giving one input, you're getting one output. That's the definition of function. Now if I say a function like this as 4x minus 3, or you will say, okay, y equals to fx, function of x equals 4x minus 3, versus another function where I say function of x equals 2x squared minus 7. What is the difference that you see between this function and this function?
The first one will plot, if you were to plot each point, you would get a line. The second one will get you a parabola.
Right. So, any response on the screen? Yes, Vishal.
Are we asking the different, like what's different between them?
Yeah, just by looking at these two functions, what would be your observation?
I noticed that if you're multiplying the first equation by 2, it's the second equation by 2, it will form like 4x, just like the one in the first.
But this is 2x. This is 2x squared.
Oh, I didn't see that.
Yeah. So see, there was a clue in the question that I asked. I said that. Yep. Yeah, Dave. Go ahead.
Wait, are we just seeing what the differences between the equations are?
Right. So basically, I'm just trying to see. This is a function, and this is also a function. Correct? And this function has this contract. This function has this contract. Correct? It says how would the outcome get derived for this function versus this function. That's what your contract for the function is. So I'm asking you guys, just by looking at these two functions, what would be your observation? And the clue that I gave was that when I started the class, I said that we'll talk about nonlinear functions. Did I talk about it so far? Answer is no. So that was another clue. So now I'm saying, when you look at this function versus this function, what would be your observation? Keeping that clue in mind. I got one answer. Yes, Sunarka.
I see one of them is a quadratic function, one of them is a linear function.
Wonderful. Okay. Any other observation? Dhanushree, Aryan. Yes, Vishal. Vishal, go ahead. You're talking on mute probably.
Oh, I noticed that whenever you insert a value, they have a difference of 4 between each of them.
Okay.
And the second one is quadratic.
Right. So that is exactly what I was trying to convey, and I was waiting to hear that answer, which I heard here from Pranit also. I'm sure everybody knows about it. Maybe you did not hit the jackpot to give me that answer. Okay. So here, I think Sunarka mentioned this. Between these two functions, one observation is if I look at this as a function, or if I look at this just like an equation, y equals 4x minus 3. This is nothing but a linear equation. Yeah? Which will plot a straight line for me. If I look at this one, this is y is function of x equals 2 squared minus 7, which is nothing but a quadratic function, a quadratic equation, which will not plot a straight line for me. It will plot a parabola. So basically, that was the observation, and that was the correlation that I was trying to draw here. When you talk about a non-linear function, function is a function. Every function, for every one input, it gives you an output. But there is a small demarcation between the different types of functions that we'll deal with. This is a function, this is also a function, nobody can deny that. But this one, this function, when you try plotting it on a coordinate plane, this will plot a straight line. This one will plot a parabola, because this is a quadratic function and this is a linear function. Now, so whenever we deal with functions, we can deal with two variants of the function. One would be called a linear function and another one will be called non-linear function. Every function that helps you plot a straight line, that's a linear function. Everything else is a non-linear function. So all the polynomials, all the quadratic function or the cubic function or any other polynomial which has the maximum power different from 1, that would be a non-linear function, because these are all tightly coupled concepts, meaning a function can be converted into an equation or can be looked at as an equation, and the equation plots on the coordinate plane. If it plots a straight line, that's a linear function. If it plots anything apart from a straight line, that's a non-linear function. Other practical interpretation from this could be that when you're talking about a linear function, your rate of growth is fixed, it's constant. When you're talking about non-linear function, the rate at which y changes, that is not constant, or that is not aligning with your understanding of the slope intercept form. Your slope keeps varying. Yeah. So all these things that we learn, right? I mean, they are always related to something that we have learned in the past, or it will be related to things that we'll learn in the future also. So that's why I'm just trying to help you guys connect with us. Yeah. Is everybody clear about that? So tomorrow, if I upload the video of this class and say this was the video for the nonlinear function, if I would have not told what I told last 5 to 7 minutes, you guys would have started disbelieving me, say, oh, this teacher says I am teaching a nonlinear function and he did not even bother to tell us what exactly is a nonlinear function. Yeah? Is everybody clear? Yeah? Dhanushri, you'll not have any complaint with me, right?
No, sir.
Okay, alright. So let's move on. So I was talking about the next thing that we're going to talk about is more with respect to dealing with equations or solving equations, right? We just looked at function which can convert to an equation, right? And you can have a linear equation, you can have quadratic equation and different forms of equations. And in the previous classes, very recently we talked about how do we resolve or how do we solve quadratic equations, right? So I'm not going to touch upon that. That is so very recent. But in general, if you look at solving equations, if somebody says there's an equation 4x minus 18 equal to 26, solve it for x, easy peasy, nobody bothers about it. You have one variable, one equation, you can easily solve it. So this is the most ideal situation that we want to get to. If we want to solve any equation, we want to convert our equations to this form where we have one equation, one variable. That's where it works the most seamless way. Now, if I say 4x, why 4x? 4 and 7 are my favorite numbers for this Sunday, it seems like. Let's say 2x minus 3y equal to 0.7. Okay? This is my equation. If I say this, and you don't have this equation with you, okay? If I say this, you will not be able to solve it. Your first response would be, no, I need two equations if I have to solve for two variables. Or in a more generalized form, you will say, I need as many equations as the number of variables. If my equation, let's say if you are given one equation which has 3 variables, you need at least 3 equations for those 3 variables. Then only you will be able to solve it. Let's say now 2x minus 3y plus 8, it doesn't give you a solution. It can give you all possible combination of x and y, but it doesn't give you a pinpointed solution for this one. Everybody with me, right? Yeah. Okay. Now, if I say x plus 13y equal to 210. Now this gives us the comfort that I have two equations and I have two variables x and y. I can solve it, right? So this is where, when you're trying to solve it, there are different methods, and I'm sure everybody knows about it. But when you go to Khan Academy, you'll see there's one section which talks about isolating quantities. So that is nothing but the basic operation methods for solving equations. Whenever you say isolating quantities, what do we mean? Let's say if I had just this equation as 4x minus 16 equal to 23. Solve it for x. What we are trying to do here is, this is where we are isolating quantities. Ultimately what we are trying to do is, we are trying to isolate x on one side of equal to. That is how my English will support me. I'll say, okay, well, after doing all the magic that we want to do with the equation, x equals something. That is the state we want to get to. And predominantly this is called isolating quantities. You are isolating things, meaning you are moving things in the legitimate way. I'm being very serious about the word legitimate, okay? Because I've seen sometimes, we in the heat of the moment we just say, okay, fine, I have to get rid of 4, I have to get rid of 16. Okay, 23 by 4 plus 16. Gone. So you have to isolate in a more legitimate way. Or if I can say, everybody knows BODMAS, right? You all know when you're doing operation, when you have addition, subtraction, multiplication, division, you go with BODMAS to define which one you'll do first. Here, it's a reverse of BODMAS, if you think about it that way. If I had to solve this one, I'll first, generally you do addition, subtraction towards the end. When you are dealing with equation trying to solve it, you do reverse of BODMAS, meaning, or PAMDAS, whatever way you have remembered it. You are doing addition, subtraction in the beginning, and you do multiplication, division towards the end. So it kind of, it's like, reversing the law of gravitation. You're doing the other way around. Okay? So regular operation when you're dealing with numbers, adding, subtracting, dividing, multiplying, you follow BODMAS or PAMDAS, whatever you call it. But when you're dealing with equations, you do it the other way around. Meaning, here, wherever you have addition, subtraction, you first finish that quickly. Bracket, we'll come to bracket later. But here, what you will do, you will move this guy this side, because ultimately you want to come to a point where you have only x on one side. So first thing you say, okay, fine. It's like a fire situation. You want to get rid of everything, move it away. So this goes to that side, becomes 23 plus 14. Now you have taken care of the addition part. This became 39. Now you will do the multiplication at the end. So this multiplication part, you know that when you have to move it, it comes here. So I know this might look a little substandard for you all, right? Because this is something that you have done enough by the time by now. But then only thing that you have to keep in mind is, whenever people talk about isolating quantities or any concept around that, it's essentially about how do you get to a point where you get the desired result by solving it. Now let's look at a set of linear equations, and then I'll let you guys practice two problems. Let's say if I have 3x minus 4y equal to 16 and x minus x plus 2y equal to, let's say, 18. I want to solve this. What I'm going to do is, at every point, I'm trying to isolate things. I know that, okay, fine, I have x plus 2y here. There are 2-3 ways, and I'm sure you guys know it. I can look at an equivalent equation, multiply it by 2 so that I get a 4y here, and then when I add these two equations, y will get knocked off. What did I do? I isolated y. Or I knocked off y basically, so that I have only x. So this is the elimination method. So when you take this approach and then add these two, so this is 3x plus 2x, because 5x, you got rid of 4y, minus 4y here plus 4y will be equal to 16 plus 2 times of 18, that is 36. So you got 5x equals 52, or x equals 52 by 5. What did we do? We just isolated x. It's like this guy is diagnosed with COVID, you are isolating him or doing a quarantine. And there are methods to follow. You cannot just do it in any abrupt way. Okay? So that's the whole premise of what we do when it comes to isolating quantities. Ultimately, you are trying to make sure that your variable for which you are trying to find the value, that remains on one side of the equal to sign, and everything else moves to the other side. That's essentially what it is when we talk about isolating quantities. So I'll not waste your precious time talking about it further, because I know everybody is very clear about this one, unless one of you raise your hand and say, do it one more time. Any questions? Anybody? Again, and if you have not done this enough, it's okay to say do it one more time. That's fine. Not only this equation, I'm talking about the concept part of it. No questions? Okay. All right. So let's go to talking about converting word problems into equations. Okay. So before we do that, I have one sample for converting a word problem into equation, and I have one problem where we are dealing with composite function. I'm kind of feeling lazy now, so I will not solve it. I will let you guys break your head with this one. So this says, let's say y is a function of x equals cube root of x cube plus 1. Which of the following below is equivalent to y of x? Here the options you have are, or let me not give you guys the option. I'm saying that y of x equals x cube plus 1, cube root of x cube plus 1. I'm saying find out the value of y of x. And there is no absolute answer here. I'm saying find out the most simplified form in which you can represent this. Does it look scary to anybody, this question? No. Srivatsal, Neil, Sarah, Savya, Anshu, Aryan. Is everybody okay with this one? Yeah. I want you guys to solve this one. This is one of the legitimate questions from Khan Academy itself. You got it? And what is cube root of 1?
Cube root of 1.
Only one.
Yeah, so
Yeah.
we can hold.
You can put one on. You can, yeah. I'm just relying on my eyesight, hoping I'm not missing anything here. No. see here, this is your x. When you're doing y of x, this becomes cube root of this plus 1. Now you have to look at cube root of the whole thing. X cube plus 1. X cube plus 1 will not get you x out. No. So basically you have to look at this as a term, and there is no cube root of this that will give you x. Yeah? Yeah. We will come to this. Is anybody close to being done? And Sri N, I think that is Jaganya, right?
No, sir, it's
Sami, you are probably
Very
12,
good.
very early for this class.
Yeah, I'll join later.
Yeah, sure. After 10 minutes, maybe 10, 12 minutes. Yeah. So, any luck with this scary looking problem?
I just had a question. Is that 3 supposed to be like that? It's like what is it like supposed to be like a whole 3, or is it saying it's like
It's cube root. It's a cube root.
cube root? Okay,
Yeah.
so yeah, that's what
Yeah.
I was asking.
I could have written it a little better, but you guys have to deal with my writing. Okay. Yes, Vishal.
I think it will be with x plus square root of 1.
Say it again.
X plus cube root of 1.
X plus cube root of 1.
Yeah.
What is cube root of 1? 1, right?
Yeah.
So are you saying that answer would be x plus 1?
Yeah.
Let's see. Let's see. So let me disclose what are the options given, okay? The options that was given in this question were cube root of x cube plus 1. This was one option. Second option was cube root of x cube plus 1 outside 1. Third option was cube root of x cube plus 2, and the fourth option was cube root of x cube plus 1 cube plus 1. So there are 4 options you have. Now there cannot be a fifth option unless this question is wrong. So I'll give you guys maybe 2 more minutes, and then I will try solving it rather than trying to act smart. Okay? Okay, so this is a classic case of composite function, okay? It might look little scary, little confusing because of the power, all those things are confusing. Right? So as I mentioned before, my first attempt, see, I have function of function. So here I want to get rid of this function first. So let's find out what is y of x. Yes, Vishal.
I got option 1.
Option 1. Okay, we'll see. So let me also do it.
Option 3.
Option 3. Okay. So let me do it, and then everybody can validate their approach and see where we are missing or what could be right versus what is not. Now we know that y of x is nothing but cube root of x cube plus 1. Okay. So this value we got. Okay. Cube root of x cube plus 1. Now So y of x will become y of this thing, cube root of x cube plus 1. Correct? We know this formula, y of x is cube root of x cube plus 1. Here you are given x as a different value. So whatever is here, that is your x now. If you put this value in this function, this equation, so you are talking about cube root of x cube. What is your x? This thing. So cube root of x cube. Sorry, cube root of, first thing is x cube. What is your x cube? This is your x. So cube of that. So you are talking about cube root of x cube plus 1. This is plus 1. Yeah. Now cube root of cube or cube of cube root, I will look at this as a rational function. Okay. So when I look at x cube plus 1 cube root, I will say this is nothing but x cube plus 1 to the power 1 by 3. And then I have this to the power 3. So this is like a to the power something to the power a to the power b. So this becomes x cube plus 1 to the power 1 by 3 into 3. These two get knocked off. So this becomes x cube plus 1. So whole thing that you have inside this, that becomes x cube plus 1. So this equation you are saying is nothing but cube root of, this whole thing became x cube plus 1. So x cube plus 1 and outside you have 1. So this becomes x cube plus 1 plus 1 2. So this is the answer that looks right to me, and I feel little comfortable because Vishal also has given the same answer. So we both are either right or wrong. Anybody having a different opinion? Anshu, Prisha.
Can you explain that one more time, sir?
Okay, not a problem. So now forget about these options, okay? These options create bias. Okay? We are trying to find out y of x. Correct? So this is
I
essentially.
got into halfway. I just I got where you put it in, plugged it into the first one into the second one. Just
Right.
from there, I don't know if I just calculated something wrong.
Bear with me for 30 seconds. I'll just make sure that I complete the entire flow so that everybody can follow me. Okay?
Okay, yeah.
So here, this is a classic case of composite function. So this is a function, I don't like it. So I will convert this into a variable. And I have a way to do so. So when I try to find out y of x, I'll first convert this into a variable by applying this formula. So y of x is already known to me, which is x cube plus 1, cube root of x cube plus 1. Or let me make my life a little easy here itself. When I have a cube root of something, if I represent that in a rational exponent form, I can tell this is this power. Yeah? Is everybody with me? Anshu, is this digestible?
Yes.
Okay. So now I have looked at both, I have kept both the options. Okay. So whichever we find comfortable, we'll use that. Now we got the value of this guy. Okay. So I will substitute that value here. So when somebody says y of x, so instead of y of x, I have a value here which I'll substitute. So I'm trying to find out essentially y of this thing, which is cube root of x cube plus 1. Or I will use my rational form, which gives me a little bit more comfort. Yeah. Now we know that okay, y of x is nothing but cube root of this. So now we got y of x. This is my new x. I'll substitute x here. So this will become cube root of x cube. This is my x. So cube root of x cube, meaning x to the power 1 by 3, 1, x cube plus 1 to the power 1 by 3, and cube of that plus 1. Is everybody with me? Anshu, are you able to see what I'm doing right now?
Yeah.
Dave, Sunarka, Vishal, everybody with me, right?
Yes, sir.
Rehan? So now I have, look at this. This is a classic example of an exponent. It's like a squared to the power cube. What does it become? It becomes a to the power 2 into 3. Correct? Here, this is my a, x cube plus 1 is my a to the power something, and parenthesis power 3. So this would convert into, if I go by this formula of exponents or this rule of exponent, this becomes x cube plus 1 to the power 1 by 3 into 3 plus 1. Yeah. Now a to the power this to the power 3 became this into this. 1 by 3 into 3. Nobody will disagree with me. This becomes 1. Yeah. So I got here in this most simplified form as cube root of x cube plus 1 to the power 1, which is nothing but x cube plus 1, and then a plus I have here. So that is how it became cube root of x cube plus 1 plus 1, which is 2. Is everybody with me now? Yeah? Alright. So I was wanting to do one word problem also, meaning pick up a word problem and then convert that to equation. So basically, that's the basic premise of dealing with equations, right? You will have a story given to you. You have to break it down and convert that into an equation, then you solve it. So since the younger kids are already joining, I would not want to get them stressed out. But one simple example would be, let's say if I say, again, interesting topic, my age, right? I always talk about my age. So 4 times my age plus 17. I don't know what is my age right now, okay? So whatever is my age, multiply that by 4, and then if you subtract my daughter's age from that, and then divide that number by 5, you get my younger daughter's age. My younger daughter is turning 15 after 4 years. Find out my age, my elder daughter's age, and my younger daughter's age. And this was a story, but it had a lot of clue in it, right? So likewise, here my age will be X, my elder daughter's age will be Y, and my younger daughter's age will be Z, let's say. And you write a story the way I narrated, and then you apply your understanding of isolation approach to find out the solution for that, or how you solve your linear equation. Again, this question was cooked up, okay, on the fly. I had a more legitimate question for you guys. What I would suggest is just go through that question which I had put in the chat and try solving by yourself, okay? And again, we have not learned anything. Just apply your brain, read it multiple times, and then try solving it. If you get stuck anywhere, you know whose collar you're going to hold. Yep. Alright. With that being said, I'll let you guys go so that I can spend some quality time with these younger ones. Alright.
Bye, sir.
Bye bye. Alright. Bye bye. Bye bye.
Thank you.
Bye bye.
Thank you, sir.
Thank you. Bye bye.